Alright, so here's the second example I'm going to do for the integral test to determine if a series converges or diverges. And it says if f is positive, continuous, and decreasing when x is greater than or equal to 1, and a sub n is equal to f of n, then this series and this integral here either both converge or both diverge. So what we'll do is we'll calculate this integral here, and if this integral is approaching infinity or something, if it equals infinity or something, then that means it diverges, that both of them would diverge. And if we take this integral here and it actually equals something, equals a number, then we'll say that they both converge. Okay. Alright, so let's take a look at the second example. Alright, so here's my series. N goes from 1 to infinity of 1 over n squared plus 1. Alright, so remember, it has to be positive, okay, positive, continuous, and decreasing. And all of this when x is greater than or equal to 1. Okay. Alright, so I'm going to say f of x is equal to 1 over x squared plus 1. Alright, and you know that satisfies. See, a sub n is equal to f of n, because if I replace this x with the n, I get 1 over n squared plus 1, which is our a sub n. Okay. Alright, so the first thing I need to do is make sure it's positive. Well, we know it's positive. N's going from 1 to infinity, and all I'm doing is plugging in positive numbers here, so this whole thing's going to be positive. And it's going to be continuous because this function here is not discontinuous. Okay, because there's nothing that makes the denominator 0. Because if you plug in 1, it's not going to make the denominator 0. 2 is not going to make the denominator 0. So from as x goes from 1 to infinity, this function's continuous. Okay. And the one thing we have to check is to make sure it's decreasing. Alright, so to test if it's decreasing, we can use the first derivative test. So we'll take the derivative, and I'm not going to show the work on taking the derivative. We're just using the quotient rules all. So if we take the derivative of this thing, we get f prime of x is equal to negative 2x over x squared plus 1 squared. And you can take the derivative of that and verify this. Okay. Alright, so now I can set up my my number line. Well, I have to set this equal to 0 to get my critical numbers. So remember, a fraction is 0 when the numerator is 0. So negative 2x equals 0. So that's when x equals 0. So we use our test points. Alright, hope you remember this. This will be from your first calculus class. Alright, so if we plug the negative 1 in, we get a positive. So that means it's increasing here. If we plug the 1 in, the numerator is going to be negative, denominator is going to be positive. So that means the whole fraction is going to be negative. So you can see that it is decreasing from 0 to 1, and certainly from 1 to infinity it's decreasing. Alright, so it meets all the conditions for the integral test. So let's go ahead and get this stuff here out of the way. Alright, so we need to integrate this thing. We're going to go from 1 to infinity of 1 over x squared plus 1 dx, okay, which is equal to the limit as b goes to infinity from 1 to b of 1 over x squared plus 1 dx. Okay, I'm assuming you still remember how to do this, and so this is equal to the limit as b goes to infinity. And do you recognize this? Okay, you can go look back in your calculus book. The antiderivative of this would be what? Arc tangent x, and we're going from 1 to b. Okay, so this is equal to the limit as b goes to infinity of arc tan b minus arc tan of 1. Okay. And so this is going to give us the limit as b goes to infinity of arc tan b minus the limit, let me write that better, the limit as b goes to infinity of arc tan of 1. Alright, so what would this limit be? Well, if you recall, and I'm sure you've done this before, you may not remember, but I'm pretty sure that you've done this. We can get this from the graph. Remember the graph of arc tan? This would be pi over 2, and this is negative pi over 2. And so the graph would look something like that. So you can see as b is going to infinity, arctan is approaching pi over 2. So this would be pi over 2 minus, and then the arctangent of 1 is pi over 4. And this is equal to pi over 4. So you can see that this approaches a number. So we would say that this series converges. Alright, so I hope that's helped. You can check out my other videos, and if you like them, you can subscribe. Alright, thanks.